Section 6.4, using systems to model data. So we want to go ahead and look at what we've been doing with systems of equations and apply it to some applications. So let's go ahead and read through this one. Scores on tests that evaluate general knowledge and vocabulary and scores on tests that evaluate memory and information processing speeds are shown in the table for various ages. The higher the score, the better the mental function. A score of 0 is average. So they're going to say let K of A be the score on a general knowledge and vocabulary test, and let M of A be the score on the memory and information processing speeds test, and both at age A years. Find equations for both functions using linear regression, and round the slope and intercept using 4 decimals. So the first thing I want to do is label the stuff in the table. The input is A in both functions, and A stands for the age. So our ages are actually in classes or ranges from 20 to 30, 30 to 40, and so on. I've mentioned this before, but when you're doing a range, the thing we usually do to kind of condense that down to a single number is pick a value in the middle. So these ages used to represent the group, these are going to be our inputs into the function. So I'm going to label these as the variable A. And then these are the scores for those people on the general knowledge and vocabulary score, and that's the K of A function. So I'll label these as K of A. And then memory and information processing is supposed to be M of A, and here's the memory and information processing. So I'm going to label that one as M of A. Sorry for that line. And so now I want to get linear regressions for both of these things. So when you do linear regression, you generally do it with 2 columns, and that's going to be the case here as well. I just want to show you what the columns would be. Our inputs for both functions are going to be in L1, and then I'm going to put the outputs for my first function in L2, and the outputs for my third function in L3. And I want to go ahead and get those put into the calculator, and then I can do the regression, and we'll also go ahead and take a look at a picture of those to see what they look like graphically. So let's go ahead and start entering that data in. So I'm going to go into the Stat menu and Edit, and I've got some old data there, so I will clear that out. And I'm going to enter those ages into L1. And then I'm going to enter the scores on the knowledge test into L2, so negative 0.4, negative 0.3, 0, 0.2, and 0.3. And just a quick comment on this while we're looking at it. They said a score of 0 was average. So the negatives would be below average, so younger people are having a below average score on how much they know, and older people are getting an above average score on how much they know. Now let's look at the memory and information processing. So we have 1, 0.7, 0.3, negative 0.2, and negative 0.4. So we've got a similar thing going on here, but it's the opposite. The positive scores are for the younger people, and the negative scores are for the older ones. So apparently as we get older, we tend to know more but have a harder time remembering it or pulling it out of our brain, maybe because it's getting so crowded in there. Alright, so let's see if we can take a look at these and see if linear regression seems appropriate. So I'm going to go into my stat plot menu, which we haven't messed with for a while, but I want to set up a second plot. So I'm going to go second and stat plot, and plot 1 is already perfect. It's a scatter plot for L1 and L2 using squares. What I want to, if I leave that alone, that's going to plot age versus knowledge. But I want another plot that's age versus memory. So I'm going to use plot 2 for that. So I'm going to select plot 2 and press enter. And I'm going to say I want that one turned on. The type of graph that I want is a scatter, so I'll highlight that and press enter. And for my list, I still want to use the same age as the input, so I'm going to say my input list or X list is still L1, and the Y list is going to be these memory scores, which I put in L3, so I'll hit second and L3. And I'm going to use a plus sign for these instead of the square, and I'm doing that just so I can tell the difference between what's a knowledge score versus a memory score. So the knowledge will be the square and the memory will be the plus. So now I want to set up the window. And for that I want to look at the inputs for the ages. They go from 25 to 75, so I could put a minimum of 20 and a maximum of 80, and a scale of 5s or 10s. I'll just go ahead and go in 10s. Let's do 5s, that way we get 20, 25, 30, and we'll hit these numbers. And then when I go to do the scores, I'm going to look for the smallest number I have anywhere here, which is negative 0.4. So I'm going to start out at negative 0.5. And the highest score I have anywhere here is that 1.0. And since all these numbers are pretty small, I'll use a scale of 0.1. So I'm looking at my data to think about for the inputs, how small and large are those for the x, min, and max. For the outputs, I have to look at both output columns at once and say what's the smallest number anywhere and what's the biggest number anywhere, and make sure I use a y min and y max that'll allow those to fit. And in fact, before I go to the graph, since my maximum output is a 1, it might be a little better to go 1.1 and just give myself a tiny bit extra room. So let me go ahead and hit graph, and we should see a plus squares plot for this one and a plus sign plot for that one. So let's see. So all I'm seeing are the plus signs, so let's see what I did wrong. If I would guess this one's just turned off. So if I go into the y equals menu, yeah, plot 2 is turned on, but plot 1 isn't. So let me highlight plot 1, press enter. Now you can see they're both highlighted, so they should both plot. And now we can see them. So the plus signs are going up, and remember we said that as you're getting older, you know more. So that's represented in the climb in the plus signs, and in the squares. And the plus signs are dropping down, and that makes sense too because our data was decreasing, meaning that as you were getting older, it was harder to pull that information out of your brain. So that makes sense. And then now what they want us to do is get equations for both of those. And so we're going to do that using linear regression. So first for the data set that has the squares, which is in L1 and L2. So I'm going to hit Stat, Calc, Linear Regression. My data is in L1, L2. And I'd like to see these graphed as well. So I'm going to store this into Y1. And the way you do that is to hit another comma after L2, go into the Variables menu, choose Y Variables, Function Variables, and then Y1 is our storage place. So I'm going to press Enter. So what I'm telling it is I want linear regression for the data in L1 and L2, comma, let's store that into Y1 in the Y equals menu. So I'm going to do that and get the equation. And they asked me to write that down, I believe, with 4 decimals. Let me check. Yep, there's 4 decimals they want. So that's the k of a function. So k of a is going to be equal to 0.0144, that's 4 decimal places, times the input variable of a, and then minus 0.7465, which is my y-intercept. And then I want to do the same thing for the memory function. So I'm going to have an MA function right below that. So to do that one, I do almost the same thing. I hit Stat and Calc, Linear Regression. My inputs are in L1, but this time when I do the comma for the second one, I'm going to do second L3 because I put the memory scores in L3. Inputs are still L1, but the memory scores are L3. And then another comma because I want to store this, and I put this one in Y1, so I'm going to put this one in Y2. So variables, Y variables, function variables, arrow down to Y2, and then press Enter. So here's my equation. Negative 0.0283, I know it's a 2, but followed by a 5, so we'll round that up. That's times the A, and then plus 1.6645, putting 4 decimals on each of those, like we were requested to do. And then I've also stored those into the y equals. So I'm just going to show you that real quick. If I hit y equals, we've got y1 equals and y2 equals, and they actually use an amazing number of decimal places on this when it stores it, so you have very accurate slopes and y-intercepts, which really cuts out on the error that we normally get by rounding like we did over here by hand. Alright, let me go ahead and move this out of the way. Let's make sure we did everything we were supposed to here. So find equations for both functions and round the slope and intercept using 4 decimal places. So we did that for k of a and m of a. Alright, so now what do they want us to do with those equations? Use substitution to estimate at what age a person's score on general knowledge and vocabulary tests is equal to the person's score on memory and information processing tests. So where do you have the same kind of amount of knowledge and memory? Where do they kind of collide, if you will? So when you do this, what you want to remember is that function notation represents the y value. So this is a y value and this is a y value. And if we use substitution, we take this value for the y on the first equation and substitute it in here for the y value on the second. Or a simple way of saying it is if you have two functions and you want to find the intersection, just take the output rule and set those equal to each other. So let me write it out this way. We want to know when does Ka equal Ma, but then what is Ka? It's 0.0144a minus 0.7465, and what's Ma? Negative 0.0283a plus 1.6645. So we set the two functions equal, we change that over to their rules, and now we try and solve this for a. So I would add 0.0283a to both sides. That's going to cancel these. And let's see, bringing in some other color. I want to move the constant to the other side, so I would add 0.7465 to both sides to cancel this off. And then let's see where we get, or what we get for that. We'd want to add the coefficients here, so let me just bring in the calculator. Exit out of there. 0.0144 plus 0.0283. That's the coefficient of A. So on the left side I get 0.0427 times A. And on the right side I want to add these numbers together. So 1.6645 plus 0.7465 is 2.411. And I want to solve for A. So I divide both sides by the 0.0427. That cancels this off here. And I need to divide on the other side also to balance. And I get A is approximately, and let's do the math on that, 2.411 divided by 0.0427 gives me 56.46. So then what is A? A is the person's age. What did they ask me to find? Use substitution to find at what age. So age is what we were trying to find. It didn't say how to round it here, so I'll just leave it there and say when you're about 56.46 years old. That would be the age where you're getting the same score on your knowledge test and your memory test. Alright, moving on to the last part. It says to verify your solution by using the intersect on the graphing calculator. So you remember when I did the linear regression, I had it store those two functions into the y equals menu. So if I hit y equals, I can see those two functions entered in, and I still have the plots there as well. So I'm going to hit graph, and we'll see a couple things. One, our first linear regression is a pretty good fit to the squares, and two, our second linear regression is a pretty good fit to the plus signs. But then we're also, when we solve this system, we're supposed to be finding the point of intersection. So I can find that on the calculator by first hitting trace, and there's the plot, so I'll arrow out of those and move on to the equation of the line. So I can trace and go to where that crosses, and it looks like around 57 years old. Remember the input was A, and the input is X on the graphing calculator. So it looks like it's around 57 years old. We got 56.46. Now all I'm doing is moving near there, so that's just a rough estimate. That looks pretty good too, 56.38, but still a little different than what we got when we did the math here. So if we want to see that more precisely, we go into the Calc menu right there, so Second, Calc. We want to find the intersection, and it's saying, is Y1 your first graph? Yes. Is Y2 your second graph? Yes, and we do yes by pressing Enter. And how about a guess of 56.38? I guess anything that's close to the right answer is good. So I'll press Enter to accept that guess, and then it's going to lock in on the exact intersection. And it says it's 56.49868. Now you might notice that's a little different. We have 46, and this is a 49. And the reason for that's fairly easy to explain. When we did our work by hand right here, we used these equations. And these equations are rounded to 4 decimal places. And if you go back and look at the y equals, the one the calculator is using has all the accuracy in it. So when we rounded this, we brought in a little error, and that error is the reason we're getting a 4.6 here, but the calculator had a 4.9. But it's still a good check on our work that it was so close, so I'm going to go ahead and say that check is satisfied. All right.